Good morning, this is week 1 Tuesday of your Physics 5 a day, and we're kicking off today with cells in series and parallel. Remember that for our cells here, the EMF is the number of joules per coulomb, that's the amount of energy per unit charge that an electron gets as it passes through the cell. Now, current, remember, flows positive to negative, but electrons flow the other way. So my electrons are going to be coming along here. They're going to pick up 3 joules per coulomb as they go through this cell, and they're going to pick up another 3 joules per coulomb as they go through that cell. So you can see that in total, they've picked up 6 joules per coulomb. This means that the EMF of the two cells in series is 6 volts. So when you've got cells in series, you add the EMFs. And you're putting energy more quickly into the circuit, so the power provided to the circuit goes up, but the time to run down is the same. If you put the cells in series, they're still going to run down in the same amount of time. Contrast that with cells in parallel now. Here, our electrons are running this way through the cells again, but this time an electron comes along here. It either goes that way through and picks up 3 joules per coulomb, or it goes that way through and picks up 3 joules per coulomb, but it can't go through both. So actually, whichever way it goes, the electron still just picks up 3 joules per coulomb. So that means that when you put cells in parallel, identical cells this is, then the EMF will just stay the same. The EMF of this combination is still just 3 volts. The power is therefore also the same. You're putting energy into the circuit at the same rate. However, because you've got two cells, it will take longer to run down. So that's the advantage of that. Now, we talked about identical cells there, and you won't get non-identical cells in parallel. So this situation here, this is too difficult to deal with. It's more like what we're doing in the second video today. But you could get non-identical cells in series. So here, again, electron picks up 3 joules per coulomb, then it picks up 4 joules per coulomb. So altogether, it's picked up 7. And so the EMF of this combination is 7 volts. So here's a little example to have a go at. Okay, so we've got 2 cells in series there, and remember that that doesn't change the EMF, so they're like a cell with an EMF of 0.7, and so then it's in series with the other cell, and so altogether that gives us an EMF of 1.40 volts.